Hello everyone. In today's class, we are going to see the topic PN Junction Diode and Zener Diode. I am Radhakrishnan, Assistant Professor in the Department of Biomedical Engineering, Hindustan College of Engineering and Technology, Coimbatore. What is meant by PN junction? So it is a junction formed between a p-type semiconductor material and n-type semiconductor material. It is created by the method of doping. So the doping is a process of adding impurities to increase the conductivity. The p side or the positive side of the semiconductor will have the majority carriers of holes and minority carriers of electrons. The n side or the negative side of the semiconductor will have the majority carriers of electrons and the minority carriers of holes. Formation of PN junction. When the p-type semiconductor material and n-type semiconductor material is placed in such a manner that it touches each other, both electrons and holes will start diffusing from one type of material to the another type of material. So under such case, when the electron diffuses from n side to p side, it will leave ionized donor on the n side. The donor is nothing but holes, the positive ions. When the holes diffuses from p side to n side, it will leave ionized acceptor on the p side. The acceptor is nothing but electrons which will remain in the p side. This region of positive and negative charge on either side of the junction is termed as depletion layer or depletion region. Biasing conditions. So we are having two types of biasing, forward bias and reverse bias. In forward bias, the p-type semiconductor material will be connected with the positive terminal of the voltage source and n-type semiconductor material will be connected with the negative terminal of the voltage source. And in reverse bias, it's a vice versa operation. The p-type material will be connected with the negative terminal of the battery or voltage source and the n-type material will be connected with the positive terminal of the voltage source. So under forward bias condition, we know that the p-type will be connected to the positive terminal and n-type will be connected with the negative terminal. So due to this process, both holes and electrons in p region and n region will have a repelling action. So these holes and electrons in the corresponding region will move towards the junction, and this will make the depletion layer become thin and narrow. At the initial range of voltage, there will be a potential barrier which is created by the depletion layer. So no current flows through the diode. When the external voltage becomes greater than the potential barrier, the current will start flowing through the diode. The point at which the sudden increase in current corresponding to the voltage increase is called knee point. The voltage corresponds to the knee point is called knee voltage. So during reverse bias condition, we know that the p-type will be connected to negative terminal, n-type will be connected to positive terminal. This will create attraction process. So both electrons and holes will move towards the electrode, and this makes the depletion layer to grow wider. Since the depletion layer grows wider, it will create a very high potential barrier and it will completely prevent the current flowing through the diode. So this is the characteristics of PN junction diode during reverse bias condition. So practically speaking, no current flowing through the junction for the initial level of voltage, but in the graph it is shown with some minimum value of current during the initial range of voltage, that is leakage current, which is due to the minority carriers. If the voltage is sufficiently very high, the device will enter into the breakdown region. The name of the breakdown is called avalanche breakdown. After the avalanche breakdown, there will be a steep increase in the current, which is shown in the graph. Now we will see what is meant by avalanche breakdown. So during reverse bias condition, a high electric field is created so that the electrons start gaining a very high kinetic energy, and these electrons will break the covalent bonds and it will start creating more and more electron hole pairs. These pairs start crossing the depletion region, and it will contribute a very high reverse bias current. This breaking of bond is an irreversible process, so it will create a permanent damage to the PN junction diode. So this is the VI characteristics of the PN junction diode. So during forward bias, so at the initial range of voltage, there will be no flow of current. When the voltage is sufficiently high, that is after the knee point, the current starts increasing, that is the device starts conducting, and it will allow the flow of current through the diode. So if the voltage is increased, the current will also increase. So during the reverse bias condition, so due to the very high potential barrier, no current flows through the diode. So at a very high voltage, the device will enter into the breakdown region. So it will be avalanche breakdown. If the device enters into the avalanche breakdown, the depletion layer will be permanently damaged, and it will not be used for the next time. The main drawback in the PN junction diode is it will not conduct during the reverse bias condition. So we can make the PN junction diode to conduct even in the reverse bias by doing some modifications. So the modification nothing but by increasing the amount of impurities, by increasing the doping level. So if we increase the doping level, we can make the PN junction diode to conduct even in the reverse bias. So such type of arrangement done in the PN junction diode is known as Zener diode. The symbol of the Zener diode is shown here. It will be similar to that of the PN junction diode. It will be having anode and cathode. So there is a small projection provided in the cathode, which denotes the cathode to anode conduction is also possible. So VI characteristics of Zener diode. So during forward bias, so it will be exactly similar to that of the PN junction diode. So during reverse bias, in the normal PN junction diode, if the voltage is very high, the device will enter into the avalanche breakdown region. So since it is an irreversible process, it will create a permanent damage. So we have concluded in PN junction diode, during reverse bias, the current will not flow through the diode. But by making the doping level to increase, we can make the PN junction diode to conduct in the reverse bias. So how it is achieved? So by increasing the doping level, we can make the breakdown to happen at the lower level of voltage itself. In the slide, it is given the breakdown name called as Zener breakdown. So this Zener breakdown occurs at the lower level of voltage, and this Zener breakdown is temporary, and it will not create a permanent damage to the PN junction. So we can say the device which is working in the Zener breakdown region, it is normally conducting. Hence we conclude with the point, the Zener diode will work both in forward bias as well as in reverse bias. Thank you.